The next major part of the chapter is about functions. Functions is already you have learnt in class 11 about what is a function and what are the major types of functions. Here you are going to learn a different types of functions. In this, the first one is called as injective or one-one function. What is an injective or a one-one function? Let me take if f of x is equal to x gives y. Right? Then if x1 is equal to x2, then f of x1 is equal to f of x2. What does this mean? This full geometrical and just full algebra, nothing is given here. We'll see what it means and what does it mean. So maybe x and y is equal to f of x. Here we have so many values. And if x1 is equal to x2, that means that f of x1 is equal to f of x2. That means that for one value of x, there is only one value of y. That is what the rule of functions. What is the meaning of functions? So what does it mean if f of x1 is equal to f of x2? So say if there is only one value of f of x, say there is 1 point, and that means that if 2 points are same, that means that only 1 point joins 1 point, or for one value of x there is only one value of y. Such a function is called as injective. Let me explain once more with the help of an example. We'll take f of x is equal to x. This is an example now. F of x is equal to x. Let me draw the graph for that. If you draw the graph for that, we can find out that it is let me define the function that is from the set of real numbers to the set of real numbers. So I'm going to draw a number line here. This is 0, this is x, this is y. So if it is f of x is equal to x, we are going to write it as y is equal to x. Y is equal to x. If y is equal to x, in the last year you have learned about straight lines, which is a straight line that is having slope 45 degree. This will be 45 degree. How do you check whether it is 1 1? So if it is a continuous line, that means that it is 1 1, and it is not going to have since it is a straight line, for one value of y there is only one value of x, and for one value of x there is only one value of y, and vice versa, and so many things. So this we can show that for one value of x, say let me take this point, this is 1 point, for this point there is only one value of x, right? That means that this is 1 1. Let me have one more example to show that it is not 1 1. So let me draw say a curve graph in the form of a graph. So let me draw a parabola. This is a parabola. So this is the value of y or f of x you call. This is x. So for one value of, let me take one value of y. So if we take one value of y here, I find that there are 2 points of x. 2 points of x. These are the 2 points. These 2 points of x give the same value of y. That means that for one value of y, there are more than one values of x. That means that this is not 1 1. Understood? Let me explain once more. See here it's a parabola. Maybe let me name this as y is equal to x square. Sorry, it's the opposite one. X square is equal to, okay, y is equal to x square. It is here you can find out that there are 2 points here. These are the 2 points which form the same value of y. From this you can understand that there are more than 1 points in the x-axis that give the value that is same value of y. That shows that it is not 1 1. If it is not 1 1, it is called as many 1. Right? It's just a common sense. It is not called 1 1. That means it is many 1. Now the second type of function. Second important type of function is the surjective function. That was injective, here it is surjective. Surjective function is also called as onto function. onto function. How do you define onto function? Okay, what is a surjective function or an onto function? I just written a simple definition of what it means. It is given in the textbook also, same thing. So if f is a function, here I am going to talk about surjective function. If f is said to be a surjective function, if it is from x to y and every element of y has some value of x in such that this is a set x. That means that every value of y should have some value of x such that f of x is equal to y in the given domain and the codomain. That's what it means. Then it is called as onto function. So let me take the same example. That's I don't know how this changed. So this is a function f r to r. That's from real numbers to the real numbers. I'm going to change. Let it be f of x is equal to what I have written here, x plus 1. Yeah, f of x is equal to x plus 1. I have drawn the graph such that with its intercepts -1 and 1. This is an onto function. I have to just prove now, just by seeing the graph, I need to explain you what is the meaning of that. So if I take the value of some y here, there are a number of points in this y. That is the meaning of every element of y here. There are a number of points and every point represents the element of the set y. So let me take one point here. This is the point I have just marked here like the previous one itself. So this if I extend this, there is some point on this graph, or what you call this is line, that has that value of y. That value of x corresponds to this y. Did you get it? So let me take, say this is the point 5. What will the value of this? What will be the value of this? How do you find out? Just by seeing the graph. So let me just substitute the value of f of x should be 5. F of x should be 5 here. What will be the value of x there? I need to find this point such that the y coordinate is 5 and you need to find this one. So x plus 1 is equal to 5. So 1 I'll remove. This becomes 4. X is equal to 4. So it is 4, 5. 4, 5 is a coordinate. That means that this x part is 4 of this. That means that for every value of this y, there is some value of x such that it lies on this graph, or such that, what do you call this, f of x is equal to y. That's what this line represents. That's the same thing. So this becomes an onto function, right? Let me show an into function. Into is a function that is not onto, like the previous one where it is not 1 1, it is called as many 1. So let me take that as the previous one itself. Let me take this graph. Maybe this is y is equal to x square. This is not straight also, it's going somewhere else. Let me take some value here and let me just show where is the function. F is equal to, f is from real numbers to real numbers, and f of x is equal to root y. No, f of x is equal to x square. That's how you need to write that. I too got confused, right? This is x square. Okay. Y is f of x is equal to x square is a graph. This is a y is equal to x square graph. This is rough, very rough here. So what I need to explain here is that this is not onto. So let me take some point on the y-axis. This is the y-axis. This is the x-axis. So there is some point here. There is some point here. Let me take one point here such that it has two values of x here. From this, the last time you found out that there is more than 1 point for one value of x such that it lies on this graph. That means that it is not 1 1, it is many 1, right? So now I'll take one point here. If I draw a horizontal line here, there is no line that is touching to this graph. That means that there is no point for which f of x is equal to this point. This is a negative y-axis. So maybe I'll take this as -4 here. -4 is equal to x square. How can a square number be negative? That is not possible. Hence, it does not belong to this. So this does not have any value of x, right? According to the definition of onto, every element of y has some value of the x, but there is no value of x here. That's why this becomes an into function. That is called as into. there is one more statement that's so difficult to understand is that, so if I change the codomain or the domain, how can I make an into function in an onto function? This is a simpler one. So I'm just explaining this one, how we are going to do this. So let me take this as a graph. I'll just rub it and draw it again. Same graph. This is 0 and this is touching the vertex here. This is y is equal to x square. I have already written. This is the function. So now I'm going to change the let me change the codomain now. Right? Let me change the codomain. Codomain, let me change it to positive real numbers, or it is 0 to infinity. What is 0 to infinity? That is coming to be the positive x-axis only. That means that the numbers that are included in the set y is from 0 to infinity in this case. I'm just going to change, I have already changed the codomain now. So let me take a point here. This point shows that it has two values of x like the previous one. Again I have one value of y, I have some value of x. So let me take one point here. So when I found that I should draw a line and it doesn't touch the graph at all, but you should not be disappointed. How it is it is not an into function here. This is an onto function because these numbers does not belong to this. These numbers do not come under this codomain. That's why these numbers are not important here in this function. They're not at all existing, right? So the numbers start from 0 only, and you cannot take any other number below that because the codomain is so much. So now it becomes an onto function because the exception in the previous case was that of a negative number cannot be equal to x square. But here there is no negative number at all. That means that it's an onto function. So now let me change. Oh, it was r here now. It was it will be 0 to infinity itself. So now it is x square, right? So just seeing this, you can make out that this is an onto function because there is no value of y for which there is no value of x, right? Next we'll go to the example questions. I have chosen the important questions in this. Now I have taken the example 12, which is the question which show that f is a function from n to n is given by, this is a way of defining a function if it has more than one conditions. So if of x is equal to x plus 1 if x is odd, and x minus 1 if x is even. I use both 1 1 and not 2. Now we need to prove that it is 1 1 and not 2. Just now we learned how to prove what is the meaning of being 1 1 and not 2. If it is 1 1 and not 2, when x1 is equal to x2, f of x1 is equal to f of x2. When onto, sorry, it's 1 1, right? Oh, when 1 1, if x1 is equal to x2, that means that f of x1 is equal to f of x2. So the converse is also true. That's how we are going to use. This is the question that comes to your mind if you have not learned about this. So generally when you need to prove that it is 1 1, you are coming in the opposite direction. So that means that if f of x1 is equal to f of x2, implies means you are going to do a further number of calculations such that you land up at the end to be x1 is equal to x2, then f is 1 1. This is the conclusion. This statement you are going to use, this is the meaning of the statement you are going to use, and that was the meaning of the 1 1ness, right? So let me see the question now. There are two things here. One is odd, when it is even. So we are just checking in all the cases. We are giving different values of x1 and x2. In the first case, let x1 is odd and x2 is even. X2 is even. F of x1 is equal to f of x2. f of x1 is equal f of x2 means, what is f of x1? F of x1, if it is x1 is positive, that means that it becomes x1 plus 1. x1 plus 1 is equal to f of x2. Here x2 is even, so I need to go to the second one. So it is x2 minus 1. x2 minus 1. So let me simplify this. I'll bring x2 this side and 1 to the, or let me take the opposite direction. Let me bring 1 x1 here and minus 1 from there. So it becomes 2 is equal to x2 minus x1. x1 is going that side, it becomes minus x1. Minus 1 becomes plus 1. So 1 plus 1 becomes 2. So this is what you get here. But you have not landed up at this case. So here it is given, you need to show that it is 1 1. That means that you are sure it is 1 1. So how do you disprove this statement? x2 minus x1 is equal to 2. How can you disprove? This is based on our assumption now. Here we have assumed that x1 is odd and x2 is even, right? So how can this be possible here? Okay, let me just take with an example. When x is odd, right? Odd is 3 and even is 16. 16 let me take here. So what will be their difference? 16 minus 3 is, it is going to be an odd number. Odd number, right? Whatever it is. So an even minus an odd number always gives an odd number. That's why this case is not possible. This case is not at all possible because of that law. Nobody has given that law as such, but you can just explain that using that even minus odd is always equal to odd, right? So you have disproved this one. So the second case is x1 and x2 both odd, both are odd. F of x1 is equal to f of x2. This is easier to explain. Here both are odd, so I need to apply x plus 1 in both the cases. That becomes x1 plus 1 is equal to x2 plus 1. So 1 and 1 I am going to cancel. This becomes x1 is equal to x2. Therefore 1 1. Okay, I need one more case, right? Directly like on right, it is therefore 1 1. So the third case comes to be x1 and x2 even. If it is even, f of x1 is equal to f of x2. What is f of x1 if it is even? It is x minus 1. That becomes x1 minus 1, right? So I'm just going to substitute the value of x in place, x1 in place of x. That's what you're going to do. Here the same, x2 you are going to replace here instead of x. This becomes x2 minus 1. Minus 1 is going to be cancelled. x1 is equal to x2. Since all the three cases hold true, you can tell that therefore f is 1 1. Right? You have proved now that f is 1 1. So last one more thing is you are going to do is f is onto. How do you prove that f is onto? We are just going to get the value of y that is f of x in terms of what x you are going to get. So case 1 in that to prove onto. In the first case, when x is odd, that means that let me mark here. I'm just writing it. Let f of x is equal to say some other variable like s. The general don't take that. I'm just taking an s. When this is odd, what is odd? X is odd. X is odd. Yeah, you're going to get s is equal to x plus 1, where s is even. Because an odd plus 1, that is odd plus odd always gives even. That's just a general thing how you are going to analyze these questions. So that means if s is even, x is equal to s minus 1, right? So that is the condition. Therefore for every even s, even I am going to tell this even number, not even like that. For every even s, there is some value of x. I just told this. Just write in small things. So in the second case, when x is even, I'm just going to repeat the same thing. I'm going to write s is equal to x minus 1. So x is an even number in this case. So even number minus an odd number. 1 is an odd number, right? So even minus an odd gives an odd number. Therefore, s is an odd number. So I'm going to get the vice versa statement. That's what I have done here. Vice versa statement is if s is equal to odd, then this bring this minus 1 this side, you get that x is equal to s plus 1. Therefore, I'm going to write the same statement. Not going to write now. For every value of even, here I'm going to write odd. So for every value of odd s, there is some value of x such that f of x is equal to y. Sorry, x, y, right? F of x is equal to y, or in this case I have written yes, right? So generally we take y so that I don't get confused here. As I have taken yes here, I am getting confused what I am going to do. Okay, this question is over. I'll just explain once more. Using this conclusion, from which that was a converse statement of what was the definition of 1 1, I'm going to prove that if it is f of x is equal to f of x1 is equal to f of x2, then x1 is equal to x2. But in the first case, I found out that when x1 is equal to is odd and x2 is even, I found out that if f of x1 is equal to f of x2, then x2 minus x1 is equal to an even number. So, but by just my knowledge, I'm just finding out that when an even number is subtracted from an odd number, or vice versa, you always get an odd number. But here you got an even number, which is not possible. That's why I'm writing the case is not possible. In the second case, I'm taking both x1 and x2 as positive odd number. So f of x1 is equal to f of x2. I'm just going to equate both of them. I get this one. So even here in the same case, and you're going to get x1 is equal to x2. That's the simple one. I'm going to the next question now. Now let us start with exercise 1.2. In this, given a function f that is defined from r star to r star. What is r star? R star is a set of real numbers minus a set 0. That means the element 0 is not included and all the remaining non-zero numbers are present in this set. And f of x is equal to 1 by x. So the first part of the question shows we need to show that it is 1 1 and onto. How do we show it as 1 1? So just in the previous examples you found out how to show that it is 1 1. So to show 1 1. So let me assume f of x1 is equal to f of x2. Since there are no more than one cases, I can just do with only one case here. What is f of x1? In substituting x1 in place of x, I get 1 by x1. Here 1 by x is present, so x2 I should substitute in place of x. This becomes 1 by x2. And taking the reciprocals on both the sides, we find that it's equal to x1 is equal to x2. So in the previous examples you found out that if f of x1 is equal to f of x2 implies x1 is equal to x2, then it is 1 1. So therefore you can write that f is 1 1. F is 1 1. Okay. Now how to prove that it is onto? So just we need to find x in terms of f of x, or let f of x is equal to y. F of x is equal to y. So y is equal to 1 by x. Cross multiply, bring x down and y down and x upwards. That makes it x is equal to 1 by y. So therefore every x has 1 y in the codomain, and every x this also means you have to just write vice versa, or just write every x has 1 y in the domain. Therefore onto, what is onto? F is onto. Okay, this is the first part of the question. The second part of the question shows you need to find whether the result is true if the domain of this R star is replaced by N with the codomain being the same, that is R star. So what is the second case is that the definition of the function is going to be changed. Sorry, not the definition, it is going to be the domain. Only the domain is changed. Here f of x is equal to 1 by x itself, but f is defined from n to r star. Right? So does this become 1 1 and onto? We'll just check whether it is 1 1 and onto. It is going to be 1 1, I think. Right? I'll just prove that we're using the same thing. F of x1 is equal to f of x2. That implies 1 by x1 is equal to 1 by x2. x1 is equal to x2. Therefore 1 1. So we should check now whether it is onto. But seeing the question, I feel that it is not going to be onto because I have already got 1 1 as the same one. So this is going to be changed because they are given another case here, right? So to check whether it is onto, if it is wrong, I can just give a counter example as in the previous ways how to get, if it is not reflexive, just given a counter example to just show that. So let me take some number, say let f of x be 3 by 2 or y is equal to 3 by 2. That is the codomain. Codomain has all the real numbers. So I am taking one of the numbers, that is 3 by 2. But there does not exist any x for which, but there doesn't exist any y, holds any x, right? Any x for which f of x is equal to 3 by 2. Therefore it is an into function, not an onto function in this case, right? Now we are going to the second question. Here the second question given is too long, so I'm just doing only a few of them, and some of them are just repetition of same things. Yes, the question in the second one is to find whether it is injective or surjective or not both of them. Right? In the first case, the question given is the function is from the set of natural numbers to the set of natural numbers, and f of x is equal to x square. Right? So you just prove that it is 1 1. To prove that it is 1 1, I need to write f of x1 is equal to f of x2. I'm going to substitute here x1 square is equal to x2 square, taking root on both sides. I'm not writing all those. You have to take the square root on both sides. This becomes x1 is equal to plus or minus x2. That means that x1 need not be x2. Therefore, but the negative sign doesn't arise in this case just because it's natural numbers, right? Only the positive sign is coming. So x1 is equal to x2 in this case. x1 is equal to x2. That is what you find out. Therefore, it is a 1 1 function. First part. The second part, to get it onto. So to get it as onto, y is equal to x square will be the form. So x is equal to root y is what you get. So seeing this one, you can find out that it is a, because it is a natural numbers, every natural number does not have a root here. Like let y be equal to some non-square number. Non-square number could be like 3. 3 is not a square of any number. That's why I'm taking 3 here. Let y is equal to 3. But it doesn't have any value of x. Any value of x for which f of x is equal to y, right? Therefore it is into function. This is second case. They just changed this one, that is the domain and the codomain. From n they have changed to the set of integers. Here the function is going to be the same, so you are going to get these two as same steps here, and here you are going to get it as x1 is equal to plus or minus x2, right? The same thing you are going to get because it is the same function. x1 is equal to plus or minus x2. But this is possible because it is a case of integers. Integers have both positive as well as the negative part. Therefore, this is there arises two cases. So it can either x1 is equal to x2 or x1 is equal to minus x2. There are two cases. Therefore, it is not 1 1, or I can call it as many one function. Right? Now to prove that it is onto or into whatever it is, first you are going to get the same thing, that is x is equal to root y. X is equal to root y. So again I think there can be a counter example for this. So let y is equal to 3. The same counter example comes here also. Y is equal to 3. The root of y is root 3, but that does not come in the integers. It is going to come only in the irrational numbers. So either it should be real numbers or the set of irrational numbers it is going to get over there. So hence this is into only again here also. Right? I'm not going to write the steps again. Just understand what is given here. So why this minus sign has come here is because integers can be negative also. Right? So let me take one example and explain you. Say f of x is equal to 1. If f of x is equal to 1, now you need to find x here. If f of x is equal to 1, that means that y is equal to 1 or x square is equal to 1. X is equal to plus or minus 1. So there are two numbers for which there is only one image. Or let me show it is in the representation of arrow diagram. This is set x, this is set y. There are 2 points that are going to coincide with the same point here in this. So this becomes a many one function. That's how I had explained, I think. Right? Now this next part of this is rational numbers. Not rational numbers, real numbers in the third part. They just changed it. Instead of writing the same steps, I am just skipping all these things. Here you are going to get x1, you are going to get the same case. Here also, in case of rational numbers, you are not going to get this case. So x1 is equal to plus or minus x2. That is the case you are going to get. Because the real numbers are positive as well as negative, it can be like this case. Right? So it is many one. Right? So, but this doesn't arise here. Let me wrap this. This doesn't arise because 3 has some root 3 also in this set of real numbers. So you cannot tell that it is an into function using that example. So I can just say that for every y in R, there exists a corresponding x in R. R is the set from which it is defined now here. Right? Let's go to the second part of that. Right? Now we are going to continue with that same question. This is the fourth part and fifth part I have written. Both of them have the same function, that is f of x is equal to x cube. And the first step is however the same, that is saying that f of x1 is equal to f of x2. F of x1 is x1 cube based on the given function. This is x2 cube. Taking cube root on both the sides, I find that x1 is equal to x2. This is direct one, so therefore you can just say that it is 1 1 function. F is 1 1. Y is equal to x cube, so I can write x as cube root of y. Right? Yeah, this is the function. Now, because it is in the set of natural numbers, again it's coming to be the same like as the previous questions, where you have let y is equal to 3 or 2, whatever, let y is equal to 3. There doesn't exist some x. There doesn't exist some x in n. N is a domain here. N for which f of x is equal to y. There is a conclusion. So if it doesn't exist, that means it is an into function. Therefore, this comes to be an into function. INTO, into. That is not taking all the y values. Here only some of the y values are taken. Right? So now let me take the fifth part. That's the same thing. The first part comes to be the same. This is the same here, okay? I can just say that the fourth and fifth subdivision is the same because you are going to get the same things here. F of x1 is equal to f of x2 here also. X1 is equal x1's cube is equal to x2 cube. X1 is equal to x2. At last you just say that it is f is 1 1. Even here you are going to get that x is equal to root 3 y. You give the same example because cube root of y doesn't exist in the set of integers. Integers are just numbers. Therefore, this you can just conclude that it is into function. Now let us go to the third question of the exercise. The third question of the exercise is about the greatest integer function. We should know what is the greatest integer function. Greatest integer function. This is the graph which you have learnt in class 11. Maybe a step graph, what you call, at the whole number places. This is 0, 1, 2, 3, 4, like that. This is minus 1, minus 2, minus 3, minus 4. Yeah, this could be any number. The points of the y-axis are very important. This let be 1, 2, 3, 4, 5, 6, and I'm going to write the numbers. 2, minus 1, minus 2, minus 3, minus 4, minus 6. Okay, this is just a rough diagram I'm going to draw. So when it is greatest integer should be less than or equal to that number. So all the numbers that come between 0 and minus 1 will have 0. No, minus 1. Minus 1 is the greatest integer, less than that. And this you will get an whole here. Because the point 0 doesn't have it here, it will have it at the same point, that is 0. It extends up till here and there comes a hole here. Hole. This is dark. The same continues here. Here it becomes dark and at the end it becomes hollow. It becomes dark, at the end it becomes hollow. This shows that how the step graph goes on. This is the graph of what? Greatest integer function. What is the question? The question says you need to just show that it is a not onto and not into, not 1 1 also, right? First we'll show how to show 1 1 and all. So let me show about 1 1. To just show it is not 1 1, it need not matter so much. So let me take, x is equal to 3 by 2 and x is equal to, I should get a number that is between, maybe 1.4 I'll take, 1.4. So according to the greatest integer of x1 and x2, let me calculate. The greatest integer of x1 is equal to how much? And greatest integer of x2 is equal to integer that is less than or equal to that number. That's the whole term. I'm just saying greatest integer less than or equal to that x1, less than or equal to x2. So if I take some number that is 1.4, 1.4 comes here and 1.5 comes somewhere here in the middle, right? This is 1.4, 1.5. Can you see? So you can just see that both of them have the same value of y, that is 1, 1, 1. This is 1, right? 1, 2, 3, 4, 5, 6. So this is 1 here. So both of them have the same thing. Therefore, which is the function here, f, I think, f is 1, 1. So how to show that it is not onto? Sorry, not 1, 1, right? Not 1, 1. Or what you call it as many one function. What to be the second part, you need to just show whether it is not onto. So for that you need to just explain how some of the points are not included in the domain. Sorry, the codomain that do not come under the range. So let y is equal to 3 by 2. 3 by 2 is some number but it is not a whole number or a integer. That's why it is not going to come as one of the range of this function. But it doesn't exist. What doesn't exist? There doesn't exist an x for which f of x, I hope this is the function f of x, I'll just write it here, f of x for which f of x is equal to y is what you find out in this. Therefore you can just tell that f is not onto, or it is going to be into in this case, right? So what do you get in this? This is the question and answer. Now we'll go to the next question. Now we have with us the fourth question and a fifth question. The fourth question is about the modulus function. I have just defined this function in the form of algebraic form. So I'll just show you the graph of how it looks. It looks like this with a slope of 45 degree and it intersects at the point 0, right? So since we just see that this is the codomain R, not the positive or non-negative real numbers, so you're not going to get a not onto function and not 1 1 also. You are asked to prove that it is not 1 1 and not onto, and the same here also. So what do you get here? So it should be not 1 1. For that you need a counter example to just show that it is not 1 1. If it is not 1 1, let me take one point y, let it be 1 here. F of x 1 is equal to f of x2 when x1 is positive and x2 is negative. I'll just take that case. Instead of taking counter example, I need to think a lot for that. So if it is positive, that means that x1, applying this positive function, x1 remains as x1 itself. If it is a negative, x2 is negative in this case, right? So you can just see that it becomes minus x2. Therefore you need to get a conclusion that x1 is equal to x2, but here you got at a wrong conclusion, that is x1 is equal to minus x2. Therefore you can just say that f is many one function, that is not 1 1 function. So next part is onto. How to tell about onto? So since this is real numbers, that's what I told, there are no negative numbers that are included in the range. No negative numbers are included in the range. Included in the range of the given function, which is the function that is f in the given function f of x. Or just give an example, f of x, or say maybe an example, I can just say y is equal to minus 3 does not have a pre-image. Say pre-image is a value of x. I am just writing in the form of proper terms here. Pre-image. Pre-image. What is the meaning of a pre? Pre is before. So y is termed as an image, right? So pre of that is before of that is the pre-image. That was just meaning of that. So we go to the fifth question now. Now here, because it's proved that it is not onto, that's however into. And should I write that? Okay. It is not onto, right? Okay, now we'll go to this part. So first again is the same thing. So this is a signum function that you have learnt in class 11 in the same chapter, relations and functions. So let me draw the graph for that. What does the graph show? This is minus 1, this is 1, and this is 0. Only these 3 points are important here. So what does it say? So if it is x is positive, then it is 1. So only in case of 0, it is not included here. So you need to get a hole here, and it is going to be continuing like this in the right direction. Similarly, you are going to get a hole here, and it is going to be continuing in the left direction, right? That's what it means. If it is only a negative number, then it is minus 1. If it is a positive integer, that means that it is like this. So if it is a 0, if x is equal to 0, it is going to be here itself. So how to show it is 1 1? I'll just take an example. 1 1. both x1 is equal to 2 and x2 is equal to 4 have same image I mean same value of y, for which f of x is equal to y. That's what the meaning. Therefore it is not 1 1. F of x is not 1 1. So I'm just showing what it means here. This is say this is 2 and this is 4 here. See, you can find that both of them have the same value of x. So if I draw the arrow diagram, let me draw the arrow diagram. This is x and this is y. X has two values and y has only one value here. I'm considering 1 here, and this is 2 and 4. Both of them join to the same point, and so many other numbers like that are there here. All the positive integers that come and join to the 1 point only, right? Therefore it is not 1 1. There are so many lines that are converging at the given point, hence it becomes a many one function, right? Did you understand? Now we'll go to the onto part. Onto, it will be almost similar here, because just by seeing this function you can find out that there are only 3 images possible, but this function gives the codomain to be R. So if I take any other number, so just to just show that it is onto, let me take, let y is equal to 3, has no pre-image, has no pre-image. Therefore the function is into or not onto. That's what I mean. So if I take a value, what is it? Y is equal to 3 means y, I have one point here, y is equal to 3. If I draw a horizontal line, it does not intersect the graph at all. That's what it means, right? The graph, it should intersect the graph, the horizontal line. That's how I can just see by just seeing what is based on the graph. Now we'll go to the next question. What does it say now? Now we have the 6th question, which has set A and set B. Set A is 1, 2, 3. Set B has elements 4, 5, 6, 7. And f is a function that is from A to B. I think you can understand seeing that f is a function defined from not R. I'm writing R, I'm writing R itself. It's A to B here. A to B. So the elements are given that come under that function. So if I write f of 1, it should be equal to 4. If I write f of 2, it should be equal to 5, because it is 2, 5. If I write f of 3, then it should be equal to 6, based on the function, based on the ordered pairs it is given here, right? So what I can conclude from this, the question is, you need to show that it is 1 1. That means that you know that it is 1 1. So you should just prove that f of 1 is equal to 4, f of 2 is equal to 3, and f of 3 is equal to 6. There are no overlapping numbers for y, or there are no more than one pre-images for a given image, for a given value of y, or an element from this set B also. So next we'll go to the 7th question. 7th question is very simple, I think. I'm going to skip that. We're going to the 8th question. Now we have the 8th question, which is function f is from A cross B, the Cartesian product, to B cross A Cartesian product. So what does it say? If I put a number or an ordered pair is the input here. Ordered pair A comma B, if I put inside this function, after processing it becomes B comma A, right? You need to show that there is a 1 1 and onto function. A simple one. I'm just going to do it fast. It's 1 1 here. You need to just prove that it is 1 1. So I'm taking a random ones as maybe x1 y1 is equal to f of x2 y2. You got it here? So applying this one, you can just find out that it is opposite of this, a b b a. So x1 y1 becomes y1 x1. That is equal to x2 y2. x2 y2 becomes y2 x2. That's what you're going to get. So just by saying this Cartesian, the ordered pairs, you can just say that this one is, both the coordinates are the same. Or what do you say, y1 is equal to y2 and x1 is equal to x2. Therefore, f is 1, 1. Right? Now to just tell that with some statements that it is onto function. There's nothing to tell in that. So you need to just tell that every number, every ordered pair a comma b from the Cartesian product a cross b as the domain. A cross b is the domain now, and a comma b belongs to that. So for every a comma b that belongs to this Cartesian product, there is some b comma a that belongs to this Cartesian product. Did you understand? I'll just repeat once more. If it is a comma b that is belonging to this Cartesian product, that's a cross b, there exists another unique b comma a. B comma a is the ordered pair and the image of this one. So for every a comma b that belongs to this, there is one b comma a that is belonging to b cross a. That's what the meaning of this. Just tell that it is an onto function. The next is the ninth question. Ninth question is very similar to the example 12 that I had taught. So I'm going to skip that and go to the 10th question of the exercise. Now we have the 10th question of exercise 1.2. It has the first set A, that is R minus the set 3, and B as the set which is R minus set 1. So function f is from set A to set B, and the function f of x is equal to x minus 2 by x minus 3. You are asked in the question, is f 1, 1 and onto? Justify with your answer. So this we do not know whether it is 1, 1 and onto. So for that we need to use that old one. F of x1 is equal to f of x2. Right? This is simpler one. This is simple after. Yeah. Okay, let me substitute here. F of x1. In place of x, I am going to put x1 here. This becomes x1 minus 2 divided by x1 minus 3. That becomes, here also I am going to put x2 in place of x. That becomes x2 minus 2 divided by x2 minus 3. Just cross multiply, you get x1 minus 2 into x2 minus 3. That is equal to this one you are going to get x1 minus 3 into x2 minus 2. You are just going to multiply now. X1 into x2 becomes x1 x2 minus 2 x1 x2 minus 3 x1 plus 6. I know you know expansion also. Okay, x1 into x2 again, you get x1 x2 minus 3 x2 minus 2 x1 plus 6. Plus 6 and plus 6 is common. X1 x2 and x1 x2 is common. So just I need to rearrange now. So let me bring 3x1 to the right hand side, and this I may bring it to the left hand side. So this becomes 3x2 minus x2, 2x2 is equal to 3x1. I'm going to bring this side, so that becomes plus 3x1 minus 2x1. That is x2 is equal to x1. So we proved that it is 1, 1. F is a 1, 1 function. So to prove that it is an onto, you need to get y in terms of x in terms of y, the opposite one. Because here you have y in terms of x, you need to get x in terms of y. So just to prove that it is an onto function, let me take f of x is equal to y. So y is equal to x minus 2 divided by x minus 3. Generally this becomes a difficult task to just get, because you get so many y terms here, right? So let's see how we're going to get that. Just cross multiply, that's the first step. That becomes x minus 3 into y is equal to x minus 2. Right, y I'm going to multiply, this becomes xy minus 3y is equal to x minus 2. Now you have to group the x terms such that you get a common factor. So this I'm going to take it to the right hand side, x I'm bringing to the left hand side. Right, this becomes xy minus x is equal to 3y minus 2. Got it? Because I want to group the x terms such that I get y in terms of x. So this becomes x as common outside. So I got y minus 1 here. That becomes 3y minus 2. So just bringing to the denominator here. So this becomes x is equal to 3y minus 2 divided by y minus 1. Right? See this y minus 1 term and compare it with the codomain given. The codomain says that there is no pre-image for 1 because there is y minus 1 term, this denominator becomes 0. So that's why they have given r minus 1 in this question. Right? So in the previous one also it is the same, because it's given x minus 3, they have given r minus 3 as the domain. So from this what you can conclude? You wanted to tell that it is an onto function. So just write the definition of an onto function and say that x and y are in such cases. Or let me tell that for every y in the domain, in the codomain, that is B, let me write it set B itself. Set B has a unique x in the set A, for which f of x is equal to y. That's the conclusion. Therefore it is what is onto, f is onto. F is an onto function. Next we'll go to the 9th question, because it seems a little bit difficult and it's a different type of question. Now we have the 9th question. 9th question has the function that is from set of natural numbers to the set of natural numbers. F of n is such that is how it is defined here. There are two cases. If n is odd, that means that I need to do n plus 1 by 2. If n is even, I need to do it as n by 2. So what is the question given? The question is asked whether f is 1 or onto, or it's a bijective function. It is asked. That's it. If it should be a bijective function, it should be it should have both the cases. That is, it should be injective as well as surjective. Injective means 1 and surjective means onto. Let's just check whether it is 1 and onto. First we have 1 function to check. So I feel that it is not a 1 function, because let me take a number like let n1 is equal to 1 and n2 is equal to 2. F of n1. F of n1 is how much? If n is odd, here n1 is odd, so I'm just taking one number, 1 plus 1 becomes 2. So the 2 by 2 is equal to 1. F of n2. N2 is 2 here. So because n is even, so I have to just write n by 2. That is 2 by 2, that comes to be 1 here. Right? So both of them have the same cases. Therefore, seeing this, I can just conclude that f is not 1. Okay? Now we are going to the second part, that is whether it is onto. If it should be onto, that means that all the numbers should be included. So let me take the natural numbers here. Just by seeing that, you can find out that it is a onto function. Right? Because it is given, the question is given, f is whether the f is bijective function. I have got that f is not 1. There is no necessity to find onto or into or whatever it is, because it is not injective, it is not bijective. Right? Therefore, f is not a bijective function. That's what you can explain. The next two questions, that are the multiple choice questions. They are simple. I think you can do by yourself. We'll go to the next topic now.